This video is on a lot of different types of graph analysis that we're going to do all throughout the course. At the end of this video, I want you to be able to say that you can do a lot of things. I want you to be able to draw a line of best fit on a graph, calculate the slope of that line, write the equation for that line in the y equals mx plus b format, and then do something called interpolation and extrapolation. We'll explain what that means. Be sure to take notes on this video, because the notes will be for points, and you can use the notes on the quiz at the end of this video. This video is going to focus on lines of best fit. And what a line of best fit is it's just this line right here. And it's used to show the general trend of the data, so that you can really see what's going on. Hopefully, when you look at this, you can see a lot of the good characteristics of a good graph. Now, what you should notice here is that most of the data points marked with X's don't even touch the line of best fit. Instead, the line of best fit is drawn so that about the same amount of points are above the line of best fit as below the line of best fit. In this example, what the line of best fit shows us is the relationship between braking distance in meters and the mass of a car. This makes it really easy to see that the heavier the car is, the longer it's going to take for that car to brake or to stop. If you go through our list of characteristics of a good graph, you probably notice something that's missing on this graph. Of course, some numbers are missing, but that's okay. That's not the point here. What's missing is a title. And remember, the easy way to make a title is to take your y and say versus x. So we could say braking distance versus mass of cars. That would be a good title. And of course, you'd want to write it neater than I can on my iPad. The next thing we want to be able to do is take this line of best fit and write an equation for it in our standard linear equation format. Y equals mx plus b. And you may have dealt with linear equations in math class, but if you haven't, we're going to take some time to review and practice that. So, all of the math that you need to know for physics, you don't have to remember from math class. We're going to talk about it here. Now remember, m is the slope of the line, and b is the y-intercept. And the y-intercept is where the line crosses the y-axis. And remember, the y-axis is the one where if you draw a big letter Y, then you can draw the y-axis. Now, I know a lot of people get frustrated when they see math, and this is what you might be thinking right here. Is you might be kind of growling. But instead of growling, when you see this equation for a line, I want you to think instead of grrr, great, because there's a mnemonic to make this easier, or a little trick. Let's check it out. Now the trick for figuring out the slope is you would want to draw a triangle. Now remember, the formula for a slope is rise over run. Or rise is the change in y, and in physics, whenever we have the change in something, we're going to use this triangle here, and that's called delta. So we're going to see that over and over again. Rise over run, the change in y, rise over the change in x, run. So let's take a look at this and do the triangle method. Now to do this, since we're worried about the line of best fit and not the actual data points, don't choose the actual data points when you're doing your triangle method. Instead, choose data points on the line that meet in a corner and make them really easy to read. So for example, I'm going to pick this data point right here and this data point, let me find one. This data point right here also meets in a corner. So, how do we figure out that slope? we can draw a triangle. And here's our triangle. What's the rise? Well, we're rising from 6 to 10. So to figure out the rise, we have to take 10 minus 6. And to figure out the run, we're going from 0.5 to 1. So we say 1 minus 0.5. If we simplify that, we have 4 over 0.5. And if you use your calculator to figure that out, you'll see that the slope is 8. Now, one thing that I want you to avoid, that's a common mistake for young physicists, is just to do the slope by counting boxes. So it's true that this does rise 2 boxes and run 1 box, and that might be tempting to say that the slope is 2 over 1. But in this case, remember that each box going up and down is worth 2, and each box going over is only worth 0.5. So don't go by the number of the boxes. Instead, go by the numbers at the bottom or at the side, on the axes. The next step to figuring out the equation for your line of best fit is to figure out b. So remember, slope is m, and b is the y-intercept. Now you don't need to do anything too special to figure this out, so I just called this the eyeball method, because you're just going to look with your eyes for the y-intercept, and that's where the line crosses the y-axis, which is right here. So, what would you call that? I'd call it maybe about 2.7. And that's going to be our b. So we have our slope of 8 and our y-intercept of 2.7, and now we're ready to plug things in. Let's do that. So the slope for a line is y equals mx plus b. In this case, m is the slope, which is 8, and b is the y-intercept, which is 2.7. Now what you can do is just swap out y and x for what they mean on your graph. So y is what's on the y-axis, which is time, and x is what's on the x-axis, which is length. So if you rewrite that, you can say time equals 8 times length plus 2.7. And that's the equation for this line. Now we didn't stop and look at what this graph meant, so let's take a look at that. So here, there's a good title, Candle Lengths and Burning Time. We have the burning time in minutes on the y-axis, the candle length on the x-axis, and this graph lets us see really, really nicely that the longer the candle, the longer the burning time. And this gives us a relationship between those two. Let's take this a little bit farther. Now, once we have our equation for a line and our line of best fit, we can do what's called interpolation and extrapolation. Interpolation allows you to figure out what's happening between your data points. So inter means between. So here's an example. What is the burning time of a 2.5 inch candle? Well, if we look at 2.5 inches here and follow this up to the top, we don't have a data point for that. But because we have a line of best fit, we can figure that out. And because we have an equation for a line, we can figure that out. So there are 2 different ways to do this. Let's check them out. The first way, and maybe the easiest way, is just to look at it on a graph. So if we follow this line from 2.5 up to the point where it intersects with the line of best fit, what we see is that the burning time of a 2.5 inch candle is around 21 minutes. Now, that's one way to do it, and it's kind of the less accurate way to do it. The other way to do it is to use our equation of a line that we figured out before. Let's try it that way and see how close it is. So our other way was with our line equation, where we have y equals mx plus b, or y equals 8x plus 2.7. Now what we're trying to figure out is y, the burning time, and what's given to us is x, 2.5 inches. So we're going to plug 2.5 inches into our equation. And what we find here is 8 times 2.5 plus 2.7. Now you might need your calculator for this, and that's okay. 8 times 2.5 is 20, and then we'd add 2.7 to that. Add those together, and you get 22.7, and don't forget your units, which are inches. And I think I forgot that on the previous slide. Now the other thing we can do is called extrapolation, and that's what's happening outside of the data points. So interpolation we'd use to predict what's happening between these two data points. Extrapolation is anything outside of there. So an example is, what's the burning time of a 4-inch candle? That's outside of our biggest data point, which is about 3.7. And just like interpolation, there are two different ways to figure it out. The first way is that you can extend your line of best fit. So if you had a ruler, you could just extend this line out farther and farther and farther until it crossed 4. And then maybe you could estimate based on that the burning time would be about 33 minutes. But that could be pretty tough. So a better way to do it might be to figure it out with the line equation. Remember, y equals mx plus b, or our slope, was 8, and our y-intercept was 2.7. So it says to figure out the burning time, which is y, and what we're going to do is we're going to plug in 4 for x plus 2.7, work that with a calculator to give 32 plus 2.7, add those together, and you get 34.7 minutes. And I just realized that I used the wrong units a couple of slides ago, so please forgive me. Anyway, remember that this video is going to be up on YouTube, so you can watch it again and again. You're going to get plenty of practice, so embrace the awkwardness of this, ask questions, and remember to use all of your resources. We're going to be doing this all semester, and the faster you master it, the less headache physics is going to be for you.